Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, happy Thursday to you all, and as usual, on Thursday we can see the weekend from here. Just at the end of the day tomorrow, and it's the weekend. Well, anyway, I want to remind you just about a few things, and since this is our third day out this week, every day you need your journal. We may or may not write in it. We will today. So have your journal at the ready. Remember to date it over on the side. Put the date in the margin so you know when you took those notes. And then your lesson planner every day. And put in it your homework. Homework for tonight. Easy peasy. John 1:3. All things were made by him, and without him nothing was made that has been made. So that's the verse itself. You're going to write it very soon, so just go over it a couple of times tonight. The meaning should be on your verse sheet or in your journal, and the meaning is Jesus made every atom that every object in the universe is made of. Wait a minute, he didn't make me. Well, he did kind of, because all the atoms that make up your body, he made. Every atom in the universe, he created. So, the meaning of John 1:3. And then a reminder about you right now are in an NBZ, a no blurt zone. Whoever is up front talking to you, it's a no blurt zone. Anytime a teacher, substitute today, or when I start talking on my lecture video, it means zip it, no talking. So, no blurt zone. So, really important. Common signals, hand up. For me, it's just start talking. Really, any teacher who just starts talking in front of you, it ought to be a signal for you to zero in right away. Well, I wanted to come back to the scientific method and revisit this Galileo experiment. Right now you are seeing a photo of the Tower of Pisa in Pisa, Italy. I've got a good friend who lives not far from the Tower of Pisa, and on that tower, Mr. C, is it really leaning? Yeah, it really is leaning some. And I think they've had to make repairs on it to make sure that it's safe. Well, supposedly, probably in the 1600s, 400 years ago, 380 years ago, the very famous Italian scientist, Galileo, climbed up the stairs to the top of the Leaning Tower of Pisa. Supposedly. We don't know 100% that it happened. And he had an experiment. What would happen if he dropped two objects of unequal weight? What would the Earth's gravity do to them? So that's what he wanted to know. And supposedly he dropped those objects. So that was his problem. On your white sheet right now, I'd like you to write down your hypothesis. What would happen? Sort of three possibilities. One, the heavier one would fall fastest and first. Number two, the lighter one would fall faster, hit the ground first. Or number three, they would hit the ground at the same time. So write down your hypothesis on your white sheet. And if you write down heavier, lighter, same, what do you think? We considered it yesterday. I wanted to return to it right away today. Hopefully you thought about it yesterday. Now it seems intuitive that the heavy object would fall faster. It just seems like it would. And most young kids, when they're asked, say that. They go, well, I think the heavier object would fall fastest and hit the ground first. So, and it seems kind of intuitive, if you drop these objects in the air, a ping pong ball is so light that it wouldn't exactly float, but kind of. That the air would hold it up some and it would slow it down. And then for sure, the heavier object would hit the ground first. Just seems like those things would be true. Okay? Well, you can't test this well, really at all, unless you do it in a vacuum. I referred to that yesterday. Unless you suck out all the air in the environment and then drop it in a vacuum. Now, you wouldn't want to actually be in the vacuum to test it because there's no air to breathe. Oh, yeah, I get it. So, anyway, so somehow you'd want to arrange to drop them in a vacuum and see what would happen. Well, in a vacuum, here's what happens. In a vacuum, the Earth's gravity pulls all objects at the same speed, pulls on them equally. So if you dropped, let's say, a bowling ball and a ping pong ball, they'd hit the ground at the same time. If you dropped them from the same height at the same time. Let's say you dropped your house and a ping pong ball from the same height at the same time. They'd fall at the same rate and hit the ground at the same time. Doesn't matter the mass of the object, how many atoms it has. It doesn't matter. They fall at the same rate. So, kind of an interesting thing. So, I'd like you to stick that in your journal. In your journal, just between heavy and light objects, Earth's gravity pulls them at the same speed. Pulls equally hard on them. In your journal. For the 6th, or let's see, actually today would be the 7th, right? It's hard because I'm taping this on the 6th. So anyway, they fall at the same speed. Gravity pulls equally hard on them. Well, I want to start doing a little mini unit on the weather. And kind of Arizona weather. We're not going to spend a lot of time on it and not too much detail. Just enough. I think it'll be interesting. I hope so. So on your white sheet, first, I'd like you to write down, what is the scientific study of the weather called? What do you call it? No, it's not weatherology. Ology is study of, right? Nope, not weatherology. What's the scientific study of the weather called? Now, there's a word that means atmosphere. Our weather is a function of the atmosphere, our atmosphere. The weather occurs in our layers of air, the atmosphere. So there's a word that means atmosphere, meteor, and so it's meteorology, the study of the atmosphere, meteorology. I'll spell it for you. Stick it in your journal. The scientific study of the weather, meteorology, 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 the study of the atmosphere, aka weather. So that's what meteorology is. Now, there are a couple of situations that affect our fall and winter weather here in Phoenix. It's kind of interesting. So first, I want you to look at a photo. You're looking at a photo of what's called La Nina. Thumb up if you've heard of La Nina before. I asked you yesterday. Besides yesterday, are you familiar with La Nina? La Nina is a weather pattern. You're going to want to put this in your journal. La, it's Spanish. L-A, feminine, I think. L-A and N-I-N-A, really easy. La Nina. Stick it in your journal. I'd skip a line down from meteorology where you just wrote meteorology. So La Nina. Now, if we have a La Nina weather pattern here in Phoenix in the fall and winter, here's what it means. It means we have drier, we end up getting drier and warmer weather. Not as much precipitation. So La Nina, you'll want to put La Nina, and then just don't write down every word and abbreviate where you can. That's good note taking. La Nina would be it's dry or drier and warmer. So it would be that kind of pattern. Not a great weather pattern for causing a lot of snow in the high country and then runoff in the spring and filling up our lakes. Not good for that. La Nina. Next is, I skip a line down from La Nina. It's L, E-L, the in Spanish, huh? Nino, N-I-N-O. And it really stands for the Christ child because this pattern is observed around Christmas, starting to form around Christmas. So, a couple of weeks ago. El Nino. And what is it, Mr. C? In an El Nino fall and winter in Phoenix, we have a wetter, cooler weather pattern. Wetter and cooler. A lot more snow down here, more rain down here in the valley and snow in the high country. It's what we want because more snow, more runoff in the spring, more water in our reservoirs or lakes. That's actually what we had last year and the year before. We had late El Ninos and we got a lot of snow, which was really good news. So El Nino. Now I'm going to show you a photo of a satellite that's going to show our weather on the west coast of the United States, including Arizona. So I want you to look at this GOES West satellite, and I want you to analyze, and on your white sheet I'd like you to write down what kind of weather pattern does it seem like it is. Now, one little bit of information that I wanted to add. When we have a La Nina, the steering winds, called the jet stream, the steering winds are way north of Arizona and push storms over northern California, over Oregon and Washington. So the precipitation from the Pacific Ocean, the PAC-O, is pushed over northern California, Oregon, and Washington. And it misses us during a La Nina. Remember I said a La Nina is a dry pattern. So the jet stream is north. So add that to La Nina. We have a northerly jet. The jet stream is to the north. So it steers blobs of moisture from the Pacific to the north of Phoenix. During an El Nino, the jet stream is shoving precipitation over Southern California and often over Arizona. That's why it's wetter. El Nino, wetter. Jet stream is more to the south and blows storms over Arizona and not way north. That's El Nino. Now here's the GOES West satellite. So you're taking a look at it, and I want you to write down on your white sheet what kind of weather pattern do you think we have right now on your white sheet. So write down either La Nina, looks like a La Nina, Mr. C. It looks like blobs of clouds or moisture are way to the north of Phoenix. or they're right over Arizona, Southern California and Arizona. That would be El Nino. So you're writing down, it looks from the GOES satellite, west satellite, and it's a recent photo today. It shows where the clouds are headed, where the jet stream is sending them, steering them. So what do you think we've got? Did you notice the big blob of clouds that are kind of to the, like Northern California and even further to the north? Mr. C, that sounds like a La Nina. It is. Right now, we have a La Nina weather pattern. It's why it's been so dry in November and December and this first week of January due to a La Nina weather pattern. So we'll keep watching it. We'll keep an eye on it. And in fact, I think a prayer is in order right now, asking the Lord to drop the jet down, cause us to have an El Nino pattern, or at least a partial El Nino pattern, and send blobs of moisture our way, storms, from the Pacific Ocean over Southern California and then over Arizona. So agree with me in prayer, would you? Lord, you know all about our dry weather, and you know all about our water needs for our lakes and reservoirs that store our water. We're asking that because of you, you would shift the jet stream to the south and begin to steer storms over Arizona, so we get a lot of snow in the high country and rain down here and rain over the reservoirs. Lord, you've done this before. We ask that you might do it again this year. Even if it's delayed a few weeks, we'll look for it and see what your decision is. So we pray in Jesus' name. Amen. So you've got La Nina, El Nino, meteorology in your journal. Not this week, but next week. No quiz this week. Next week, a quiz, and it will include the weather information. It will also include John 1:3. So it'll include that and what it means. So now I want to just make one point about John 1:3. When man builds something, all man does is rearrange the atoms that God made. That's all man does. Humans, I don't care if they're really smart scientists, they can't make matter. They can't make atoms. All they can do is rearrange the atoms to make things. And that's a trick to be able to do that. But the real trick is be able to make atoms in the first place out of nothing instantaneously. Now we're cooking about being able to do something. Oh wait, that would take a God to do that. Yep, that would be Jesus who did that. Man just rearranges atoms. Jesus makes atoms. So anyway, now looking at the time, I'm going to give you just a quick 1-minute break to just catch up if there's anything that you missed, and your sub can help you if you missed anything. You got to have your hand up, not just blurt. So if there's anything you missed at this point, you can get it in place, and then I'll be right back. And I've got, I think, a super interesting topic, couple of super interesting things to drop on you. We'll do that shortly. Take just a quick break. All right, let's get rolling again now. So let's roll it. And I found out something over Christmas that really challenged me. Scientific, okay? And it's about our bodies. It's affected me the last number of days. How long have you been doing this? I've been doing this now about 4 days. I'm doing pretty good with it. So, and here's what I discovered. Whatever it is that I'm going to talk to you about in a minute, you need to guess what it is and write it on your white sheet. Got to use that white sheet. When I ask you to use the white sheet, it's not an option. Got to use it. I often ask you to make hypotheses. This is the case now. Can you think of one thing that you could do on a regular basis that would reduce your fatigue? Now, don't say anything out loud. Just think about it. reduce your fatigue. That means how tired you feel. Now, I know this already. Middle schoolers, junior hires are growing so fast, they're often tired and need extra sleep because of it. Your body, your cells are dividing and dividing and dividing like crazy. Your bone cells, everything. And that's why you're often tired, because you're growing. So that fatigues you. But this will help with that. It'll lessen the fatigue. Your heart will be healthier because of it. Less fatigue, heart is healthier. It helps to keep you cool. Helps to keep your body temperature in the 98 Fahrenheit range. So cooling, a cooling function. Your muscles and your joints will be more lubricated. So it's healthier for your joints and muscles. Your skin will be healthier because of this. Healthier skin. Your digestion will be more efficient. You'll digest food better. By the way, one of the best things you can do to digest food, this pops in my head really quick. Use these babies right here that God gave you. Use your choppers. Chop your food up into little bitty bits, and also savor your food. It's an SSR. So savor it. Eat slowly, chew really well. By the way, when you chew really well, that helps your digestion. No, that's not the answer that I'm working for. So, but it's just an aside. So your skin will be healthier. You'll have more better digestion. It'll cleanse your body, cleanse your cells better. Just cleanses your body. Your body will be healthier because of it. It gets rid of things in your body that shouldn't be there because of this one thing, one activity. And then your metabolism will be better. That means how fast, the speed at which your body uses energy. Partly digestion, yes, but more than that. So on your white sheet, write down what one activity that you and I could be doing would reduce fatigue, give you a healthier heart, cause your cooling system to work more efficiently, lubricate your muscles and joints regularly, keep your skin healthier, aid in digestion of food, cleanse your body on a regular basis, which needs to happen, and then help with metabolism, how quickly and efficiently you use energy, food that you eat. So anyway, what one thing will benefit all those things? Here it is. Glug, glug, glug. Hydration. Water. Drinking water. Now, many of you are involved in a sport and your coach preaches this at you all the time. Hydrate, 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 right? So, but if you haven't been really consistent with it, highly recommend that you drink more water. Now, I'm not going to tell you how much you, as a young person, a growing young person, need to drink. I don't know exactly. You might ask your PE teacher. Okay? I don't know exactly, and I didn't research it. I have an idea, but I'm not going to say it. So, but you might just mention it to your parents. So now, adult men need to drink 8 to 10, like 10-ounce cups of water or glasses of water a day. 8 to 10. That's like, if you do the 10, that's like 3 liters of water. Just spread out during the day, and I'm trying to do that. I've been very successful at getting about 80 ounces, or about 80% of that 3-liter figure that I'm aiming for. So I've been good at getting 8 cups, 8 10-ounce cups. So anyway, for you, it'd probably be less than that. So But ask a little bit or go online, talk to your parents about it. So if you've got a parent who is a doctor, or a nurse, they probably have a definitive answer for you on that. But check it out. See what they say. So anyway, so next, how are we doing time-wise? Good. I have a mystery to show you. A mystery. So I want to show you this. And what I want to ask is, and I'd like you to write it on your white sheet, how was this picture taken? How was it taken? How do you get a picture like this? So please don't discuss it with anybody. Just write down your hypothesis. How could you, let's say you had a camera, how could you take this particular shot or photo? Here it is. Mystery photo. How could you get this photo? What would you have to do? Write down specifically what you think you'd have to do. Do you see the kind of like light lines, the curved light lines? They're a clue. So you've got a hypothesis, right, about how you would get this particular picture, how you would get it. Now, here's a little clue. Did you see these light lines? They go about 180 degrees, a little bit more, about 180 degrees. So how could you get this picture? All these light lines go about halfway around the circle. So how do you get it? Here's what you do. What time of day do you think this was taken? Duh, Mr. C. It looks like it was taken at night. It was. This is a night photo, and you probably had a camera on a tripod so it wouldn't shake at all, and you probably aimed it at one area of the night sky, and then you could get this photo. So what would you aim it at? What do you think this object is right here? See that? What is that? I'm going to read to you what it says, where it was taken. It was taken in Salt Lake City, Utah, at the Hansen Planetarium. Hey, did you see this little clue down here at the bottom? Now I'll raise it up a little higher. See that? Oh, that's an astronomy planetarium. So what was it aimed at? Well, it was aimed at an object that stays right in that part of the sky and just moves a little bit. Those were stars around the North Star, and as the Earth is rotating, you get that line. So the Earth rotates, the stars are staying in the same place. So the Earth rotates and gives you those lines. Kind of cool, huh? So anyway, really neat mystery photo. So it says star trails around. Actually, this is the south celestial pole. It's not the North Pole. There is a star, a pole star, right above Antarctica. So if you aim it at it as the Earth rotates, that star that's producing light will look like it moved. So, and this was taken at actually an Australian observatory. Doesn't say exactly where. And it's almost 12 hours. It's a 10.5-hour exposure. Anyway, So I hope some of you were on top of that and got it right. So, and now here's what I'd like you to do. I'd like you in your journal, in that weather section, the meteorology section, you are going to have a title. The title is going to be Kinds of Clouds. So I'm going to teach you 4 kinds of clouds. There are, I don't know, meteorologists get really picky and they get a little too into it as far as naming clouds. They're a little too picky. Well, they're scientists, what do you expect? But I'd like us to just do 4 kinds of clouds. And I'd like you, it'd be kind of cool if you could remember these. When you're outside and you see one, you go, oh yeah, look at that. So we'll probably only get 1 kind of cloud in today. The first kind of cloud are very high altitude clouds, and they look like feathers. They're just feathery. Beep, beep, beep. So as you draw this kind of cloud, you can number these 1 through 4 and skip lines, several lines, and have little drawings. This first kind of cloud are called cirrus, 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 cirrus. And they look feathery, they're not very big. Cirrus, 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 cirrus. So you might see if you can see any after school or at lunchtime. Just look up, see if you can see any cirrus, cirrus, cirrus clouds. So have a look at those. And then there's a second kind of cloud that I'd like you to know. And this one is a fair weather cloud. When you see these, it usually means dry, sunny weather. They're clouds that look like this. They look like popcorn balls, or they look like cotton balls. So, and they're a fair weather cloud. It means you probably got sunny weather, clear weather, good weather. Okay, so here's the name. So draw this one, number 2, cumulus. Cumulus. Looks like a bunch of cotton balls. Cumulus. They're not super big. Cumulus. Could you spell that for us? Sure. C-U-M-U-L-U-S. Cumulus. Cumulus clouds. So you've got the really high altitude feathery ones. What are they called? Cirrus, 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 cirrus. And then you have the puffy, cotton bally ones. And what are they known as? Cumulus. Okay, cumulus clouds. Okay, the other 2 kinds of clouds tomorrow that I want you to do. So I know many of you will look them up tonight on Google just because you're so excited about the kinds of clouds. I'll show you pictures of them tomorrow. I'll show you a nice little chart of all the different kinds of clouds, and you'll go, boy, I'm glad we don't have to learn all of those. So anyway, the other 2 major ones tomorrow with an explanation. Homework tonight, John 1:3, go over it, work on it from your verse sheet. So if you don't have one of those verse sheets yet, your sub can find some of those over by the door that you go out of on that white shelf. So verse sheet, John 1:3, and the meaning, Jesus made every atom in the universe. Jesus made all matter. He made it all. So we'll leave it at that. So tomorrow it'll be Happy Aloha Friday. So look for my Happy Aloha Friday shirt. Another surprise or 2 for tomorrow. And I'm going to let you check in now with your sub. And if there's anything that you missed, that you need clarification on, you'll get help. Okay? See you tomorrow. Adios.